Hi everyone, welcome to this webinar as part of our Robots to the Rescue series. We're excited to have you all join us again tonight for this panel. So for tonight's agenda, I'm going to do a quick overview of the competition if you haven't heard of Robots to the Rescue. Then we'll get into some, oops, didn't change that title. Then we'll get into our panel and then the Q&A. So the challenge is to design a robot that solves a current world problem. And so you can sign up for that and see any rules and guidelines on our website. And so you can stay up to date with that by signing up for those emails. And then if you want any clarifications, you can email first@ptc.com. And we're definitely happy to answer any questions you may have about the contest. Just a reminder, this Friday, we're going to be sending out that submission form. So you can be submitting for your team and then have to submit by May 15th. And then we've had several webinars throughout this period, and then we're going to have a couple more. And so for those webinars we've already had, you can find the recordings on our YouTube channel. And then you can find the upcoming ones are going to be preparing your submission for Robots to the Rescue next Thursday. And then we're going to have an office hour where we can answer any questions you have about Onshape or about that submission process. And so the way tonight's going to go with this panel is you'll have the option to input questions here. So if you go to this URL you see at the top of the screen, you can actually be inputting your questions if you have any, or you can be voting on the questions that you're most interested in hearing us talk about. So if there's something you really want us to say, you can upvote that. And so then we can try and get to that as soon as possible. But to start, I'm going to introduce our panel. For the moderators, I'm McKenzie Brunell. I work here at PTC, and I'll be joined by Mark and Dom, who will be in the background answering any questions and running some logistics. And then first, I'll hand it over to FRC Team 319 to introduce themselves, Ty and Dominic.
Hey everybody, my name's Ty Tremblay. I'm one of the mentors on Team 319. I joined FRC in 2004, and I've been mentoring Team 319 since 2012. And Dom here with me is a student on 319.
Hi, I'm Dom. I'm a junior. I joined the team when I was freshman. I've had a lot of fun doing FRC and have gained a lot of experience from it.
Great. Next, I'll hand it over to Eric to introduce yourself as well.
Hi, I'm Eric Leifermann, lead technical mentor at Team 2026, Wave Robotics. I've been doing FRC since I just finished my 19th year. Freshman year was the 2002 season in high school. So yeah, I've been on Wave since 2012. And, yeah, I mean, I have a great time, so I keep coming back.
Great. And then I'll hand it over to Mike and Nathan at FRC Team 1678.
Yep, Mike Corsetto, lead technical mentor for 1678. Been in FRC since 2004 and mentoring 1678 since 2008.
And I'm Nathan. I'm the hardware design lead on 1678 and also the robot operator.
Great. And next we'll have Julianne come on from FTC Team 11770.
Hi, I'm Julianne from Team Curiosity 11770. I'm a sophomore and I've been on this team for 4 years.
Great. And next we'll have FRC Team 4909. Blake and Matt can introduce yourselves.
Hey, I'm Matt Flood. I'm from FRC 4909 Vionics. We're a 7th year team. Been with the team since we started. I am the head coach and also I am a physics and engineering teacher at Billerica Memorial High School.
Great, thank you all. And so just to start, we wanted to show a few of the robots as well. I have 319s right here, if you'd like to talk about that. Oh, as it comes up.
It might take a while to load. We put everything in there.
Not a problem.
Yeah, so 319's been designing our robots in Onshape since the 2016 off season, where I picked up Onshape from a recommendation from a coworker and just started trying to recreate our 2016 robot. That went pretty well, and then I found the learning pathways for Onshape and realized I'd been doing things completely wrong. And so since 2017, we've been a Onshape team, trying to use Onshape like Onshape should be, and we've really enjoyed it. As Dom can help back up, we've been really appreciating the fact that there's no installs and that we can just send somebody an email and get people involved, right, Dom?
Yeah, I've had the experience. It's very easy to use Onshape, as like Ty mentioned. It being in browser base has eased up a lot of complications for many of our team members to be able to work on it.
Great.
So-
And I see here you have a lot of different documents. Like you said, you kind of put all those things in one place so team members can find everything.
Yeah, we have one top level assembly and then an assembly with our top level assembly plus like a gaming or a game element. And then we put folders for each of our subsystems and their subcomponents, and from there on.
Very cool.
And then in our top level assembly, this year we worked on adding configurations just for typical parts of or typical poses for the robot. So we're able to extend and retract the collector using the configurations on the above the feature tree. And then we can also make it so that the turret is free to pivot around. And this helped us really understand how the two subsystems interact.
Very cool. And then I also have the CAD from 4909 if Blake and Matt want to talk about what they've been able to do in Onshape.
Yeah, so this year was a really great year. We had like more than half the team in the CAD at the same time working on disparate subsystems, and the pieces really kind of came together. We started out last year and had a really hard time figuring out how all the pieces, all the subsystems fit together. And what we tried doing this year was, before we even went into CAD, the leaders of the subsystems got up and went to the whiteboard and kind of sketched out and said, you know, I need this area for the ball intake, I need this area for the manipulator, I need this area for the climber, and that area for the shooter. So we had a two-dimensional view, and everyone kind of had the same picture in their head before they went into the CAD and figured out the details.
Very cool. Definitely a good process. And then I don't know if any of the other panelists have their robots ready and available to show. We can share this, switch over the screen sharing to you if you'd like to.
Yeah, McKenzie Nathan has some documents that he can share if he can get a screen share.
Perfect.
Yeah, I can go after.
Nathan, you should be given access now.
All right, there we go. My screen is it seen?
Yep.
Yes.
All right, cool. Yeah, this is our top level assembly from this year. So this year we decided, just due to load times, to keep all our assemblies separate. So you'll see our top level assembly is just in a document by itself, and then I have the shooter, for example, pulled up here, a document all by itself. And then the way we try to manage like the integration of all of them is, at least for all the assemblies I designed, I put this clear box at the bottom in the middle, where the middle of the robot would be on the ground, so that when we put everything into the top level assembly, we just made all the boxes together and then we're good to go. That's kind of how the integration worked this time. And then obviously you have to do some separate initial geometry sketches for each thing you do, just to make sure everything carries over between documents, but it wasn't too much of a hassle. Yeah, that's pretty much it.
Great. And I think, Eric, did you say you'd go next?
Yeah, I can go next.
Perfect.
Is everybody seeing it?
I see your desktop.
Yeah.
How about now?
Yes.
All right. So yeah, it's kind of blown up at the moment. Had a really young team this year, so we switched to Onshape in 18. So fall of 18. So this is our second robot we built in it, and my CAD team exploded from 2 kids to like 12 kids. because of it. So lots of learning, lots of stuff, but we're kind of in the same way that everybody else is, where we just we've got a folder, different part studio down at the bottom for each individual thing. We don't do the whiteboard thing as much. We have like an actual just like sketches, and we just do a bunch of 2D sketches to figure out robot, layouts and everything. Short, tall, arms, different types of intakes. Also, and so that's our whiteboard is in here. But yeah, main robot assembly. I really like that configuration thing, Ty. So I think we're gonna probably steal that.
Thanks. It helps when most of your robot moves with pneumatics, but when we'll figure out something when we get a motor controlled actuator again.
Yeah. We had no pneumatics this year, so it was interesting.
Very cool. And then Julianne, are you ready? Do you want to show your robot?
Yeah, it's pulled up on my screen. If you could share.
Okay. Yep, absolutely.
Yeah. So is it sharing? Yeah.
Not yet.
Yeah. Okay. My computer's not letting me screen share. Sorry.
Oh. Always the challenges with these various ways of conference calling we're all dealing with. We can, if you can send it over to me, I can share it later on. We can get started with a couple of questions while we pull it up.
Yeah.
Perfect. And so a question I actually have for you all is, how do you organize your team? Do you have a teams in Onshape? Do you set up your teams for sub teams? I can kick it over to Ty and Dominic first to answer that question.
Yeah, so we have in our whole team, we have separate sub teams. So CAD is one of those teams. So we'll have designated people to be on CAD, but we also encourage people to, if they want to explore CAD from a different group, or if they want to go from CAD to a different group, we allow that. But the idea is to kind of have a set team that does it.
Yeah, and from there we also have members that are on the CAD team that are part of the team developing different parts of the robot. So the collector team or the drivetrain team, and they're all logged in at the same time and working on certain parts of the robot. And then specific to Onshape, we've created a team 319 Onshape team, which makes things really convenient because we can just add new students to the team, and then they automatically have access to all of 319's documents and libraries. That has proved to be very, very beneficial for us.
Cool. And Eric, what about your team? How do you organize yourselves in Onshape or otherwise?
I mean, I think it's pretty standard FRC. You split up to your different subgroups. Pretty much do the same thing 319 does when it comes to the CAD. We break out into prototype groups, and they have kids from each different subgroup. Make sure that the CAD students are separated between all the different prototyping groups, and that way they can draw anything up that the prototype team needs. And they basically just lead the process through, CADing to manufacturing. That's basically it. I mean, we don't use like I said, we've been a really small CAD team until this year, so this year was a little bit different. But yeah, we have a 2026 team set up in Onshape, and I just add students as they ask for it.
Perfect. And Julianne, I'm just wondering if you do anything different as an FTC team, if you guys are organized a little bit differently.
Yeah, so as FTC, our teams are a lot smaller. So of our team of 14 people this year, we all kind of split up into different groups for each mechanism, and then those groups together in groups of like 2 or 3 CAD'd that particular mechanism or subassembly. So it's kind of different that like everybody on our team participated in the CAD, just because we have many fewer people than like FRC teams, but we were still able to get it to work and make our robot in Onshape.
Cool. Matt, what about you?
So I think, we follow a lot of like what Eric and Ty, or how they organize their teams, where we have our, our subgroups for different parts of the robot. And, we expect all our kids who work on the robot to be, using Onshape and CAD. So, we'll have a full lab at some points, but, we also do we set up our own team in Onshape so that all our kids have access to all our files and our documents, and they're organized by year. So, depending on the year, the robot that we're working on, or they want to go back and look at something, it's pretty easy to go in and take a look at, what we've done in the past.
Very cool. And then Mike and Nathan, do you guys organize similarly?
Yeah, so we do have an Onshape team set up. I was just looking at our Onshape team to see what what our utilization is like, and actually I think this year we've done an even better job at. We're pretty segmented on our team. We have design students, we have manufacturing students, and there's a little bit of like crossover functionally, but they tend to be pretty separated. But one thing that we've been able to do with Onshape that we weren't able to do with other platforms is, since we assign part numbers to every part, and that's applied both in our parts tracking sheet and in our Onshape document, when there's like, especially maybe a router part that needs to be made off of a CAD file, rather than the designer needing to produce the DXFs, we've gotten to the point where our manufacturing students are able to have access to our Onshape model and navigate to the proper document and find the part and produce the latest DXF straight from the model. So in addition to all the kind of the stuff everyone else said, we found that Onshape lets the CAD be more accessible to other auxiliary points on the team that aren't necessarily like core design, to be able to like produce parts and make progress on the robot.
Very cool. And so then I'll pass this next question back to you, Mike and Nathan. Are there any specific feature scripts you guys have found helpful in creating your robots each year?
Nathan, you want to talk about some of the ones we've used in the past, and then I'll talk about some of the ones I'm excited for?
Yeah, I'd be happy to. So in the past, I guess in the last year or so, the main feature script that we've been using is called Lighten. What it does is it does pocketing for you pretty much, which is pretty nice. But it does eat the load times. It really slows them down. So that's the for instance, on a belly pan, we're not able to use that because it's just so slow to load. Or I guess the other one that we used this year was a laser joint feature, which we use for some parts on our Wheel of Doom to make the CAD for them really easy and easy to assemble. And then Mike, if you want to talk about the ones we are just getting into.
Yeah, so we were talking before the show, but we're working on a couple of off-season robots designs right now. And there's been a couple really great feature scripts that we've come across since the start of the off-season. So a first community member, Julia, has produced a couple of really awesome feature scripts. We've been heavily using the tube converter feature script that they created, where it basically takes a solid model of a 2x1 extruded solid, or a 1x1 extruded solid, or a 2x2 extruded solid, and applies our standard hole pattern. And there's even a 1678 mode in the feature script, which is really convenient for our students to know which one to use, which is pretty great. And then also, I think through Julia, we heard about this vent feature script, which is essentially a slicker version of the Lighten feature script that we have been using, and it's much less process intensive. So those regen times drop down really significantly when you're doing similar things with the Lighten versus the vent feature script. So finding ways to not only like do the things that we need to do with Onshape, but also be better resource efficient. And I think both those feature scripts are going to prove really useful in upcoming seasons.
Yeah, the downside I've found with the vent feature script is that it doesn't let you kind of define how the stress gets propagated throughout your system, because it just takes a shape and patterns it. So it works great for things like belly pans and stuff like that. But yeah, it's definitely a cool one.
Mm-hmm.
Do you have any others that you use, Ty and Dominic?
In terms of feature scripts, I think those basically cover it. But we've been really big into the MKCAD parts libraries. So inside there are definitely some other feature scripts that can help generate like tube axle for us. We really like the ability to just go in and insert a configurable Thunder Hex shaft like from VexPro, or being able to generate a configurable motor, which is really cool. But I think, yeah, 1678 covered most of the feature scripts that we use.
Yeah, and actually one of our second, I think it was our second webinar, we went into the MKCAD parts library and showed some of those feature scripts. So anyone who's listening, you can go back and watch that recording on our YouTube channel if you want to actually see a demo of some of those being used. And then Julianne, do you have any specifics that you've used?
Yeah, so we do a lot of laser cutting on our team because our robots are smaller and we're able to do that. And so we use the laser joint feature a lot to get parts to fit together when we assemble them, and also kerf compensation because it allows us to make sure that the holes are like the right sizes when we laser cut something so we don't have to drill them out. So that is something that we found to be very helpful to us.
Very cool. And then what about you, Eric?
Yeah, we don't use a lot of the feature scripts. We basically just use MKCAD at this time. We're still learning lots of, like I said, really young CAD wise this year, team wise, really. But yeah, still diving, learning stuff even from this. You know, write those things down to show the team and hopefully make things better.
Perfect. And then Blake, I know you're pretty familiar with feature scripts, so what ones have you guys been using?
Yeah, I'm not sure if it's the same as the one mentioned earlier, but we use the custom length extrusion feature script very heavily, and that's fantastic from a standpoint of not having to draw the profile of the aluminum tube. You just pick rectangular tubing, and then I want a 1x2, and I want 16th wall tubing, and there it is. And they have many of the Andy Mark and Vex specific products, such as the Churro and the Thunder Hex, which we made pretty extensive use of this year.
Cool. Thank you all for that. We'll look and see what our next question is.
I just remembered one, sorry.
No problem.
There's a feature script called set material. One of the things that we do in FRC is it's important for us to have an understanding of whether or not we're going to be within the weight limit. And there's currently in Onshape itself, there's no way to just say this thing weighs X pounds. So we use the set material feature script to kind of back calculate a custom material with the proper density to make that thing weigh the right proper amount. And that's helped us get really accurate weight estimates.
I'll echo that. We've used that hack a couple of times.
How accurate have you found your weight measurements to be?
Like we're close to within half a pound, but then we were also like 15 pounds underweight this year, so we didn't really care that much.
Awesome. So the next question I'll ask you all is, how do you introduce new students on your team to CAD? I know that's definitely a challenge as you get, I know especially Eric, you mentioned you had a younger team, so I'll probably start with you for this one, but how do you introduce your team members to CAD?
So we like to do a one-day boot camp kind of thing. They come in on a Saturday, and we have veteran students, sub-team leads. They each do some type of project that you can be taught in 20-30 minutes, kind of just a quick overview of what each sub-team does. And so then we split the rest of the team up, and they kind of just one by one go through the sub-teams. We do other various team bonding activities, have lunch, all that stuff. But that's how we show them everything that each sub-team does. So hopefully they can get a, hey, I like robots, I want to join the team, but they might not necessarily know that we manufacture it, design it, we program it, we wire it up. There's the business side, so we write essays and we do presentations and all that stuff. So we do a boot camp to really get them just a quick overview, and then give them opportunity to pick a sub team early that they know they're going to like, and kind of just go from there. But when we switched to Onshape in 18, it was basically a way for me to still be a mentor. Actually, my wife gave birth to our first child in October of 2018, and I was so dedicated, and I was going to be there all the time, that have to have balanced life priorities with robot priorities. So switching to Onshape allows me to sit at home and still spend time with my wife and kid while I watch the students do their CAD from their build site, and then I can message them on Slack or even just put messages in the parts and be like, hey, this isn't working, or have you thought about this? And it's allowed me to cut back from 5-6 days a week to 3, so which is really nice.
Very cool. Yeah, and I know too for teams that here in the Northeast, we tend to deal with a lot of snowstorms during the build season. So I'm sure that's great for a lot of other teams too that are trying to manage all of that and figure out how to meet remotely more often. Julianne, do you have any tips on how you've introduced new students on your team to CAD, or how you got introduced to CAD?
Yeah, so since on our team, kind of pretty much everybody CADs because it's a much smaller team. When we have new students, we kind of start off with doing like different types of CAD exercises and trying to CAD like a certain assembly or a certain part. And then once we start actually getting into CADing and assembling the robot, we kind of try to distribute the group so that there's experienced members with the newer members, and then we kind of help each other out in like with CAD, and we try to make sure that everybody's involved and everybody kind of learns along the way as we're designing the robot and designing new parts, so that people are like learning to make custom parts, but also learning to put assemblies together to help build the robot.
Very cool. And then Dominic and Ty, do you have any tips for how you introduce new students to CAD?
Yeah, so kind of like how Julianne mentioned, in off season is usually when 319 gets a lot of their new kids because school is coming back. So we tend to kind of introduce everyone to different subgroups, as I mentioned, and especially for CAD, kids who are interested, we go through different processes of using different features of Onshape. And then once it comes to build season, we go along with that, and kids are able to learn from more experienced students on the team as well as mentors. So that's how I was kind of brought up through the team, was when I joined. I was taught from a high level student, upperclassman, I mean. And then as it went on, I became that upperclassman, and I've been teaching kids how to use Onshape as well.
Yeah, we find that there's kind of two things you have to learn if you want to get good at CAD, shall we say. We find that you have to learn how to use Onshape, but then you also have to learn how to just design in general. And there's a lot of great online resources for that, but we found the best and most effective thing is practice. So that's why we do these off-season projects.
Awesome. And then Nathan and Mike. Oh, nope, you can go ahead, Julianne. You had.
Oh, sorry, just something that add on to something that Dominic said, that like we started using Onshape and CAD only a few years ago, and when we first did that, kind of everybody was new to it, and it was pretty challenging for us to like get started. But once we were able to kind of CAD some parts and gain more experience, it was really helpful, and we were able to help like other members of our team, especially the new members of our team, learn how to use like the software to make different parts to help build the robot.
Awesome.
We actually started teaching FLL kids Onshape, which has been really helpful. It's also part of the reason why my CAD team exploded the last 2 years. So
that's awesome. Nathan, do you have any feedback on how you kind of got introduced, or how you introduced other students?
Yeah, so me personally, I actually used SolidWorks my first year on the team and switched to Onshape my second year. And in terms of like learning Onshape from SolidWorks, the Onshape's like training, their courses and their learning pathways were super helpful. And we have all our new members go through those as well. And that's obviously to learn like how to use Onshape, the functions, the features, all of that. And then we also do off-season projects. We currently have an off-season robot that we usually have like core designers during the build season who kind of manage some of the main assemblies. And And so we use the off season to kind of delegate to some of the newer members. So we have all of them working on an off season robot and kind of learning the process of CADing parts and putting together assemblies and how a robot kind of comes together. And obviously they're going to keep learning through the off season as we assemble the robot as well. But traditionally in their first year, their first major project is CADing a 1678 style West Coast drive. And then we also do some pneumatics motion training and just some general FRC applicable training as they go into build season. So they have some recognition of how everything works and can contribute. Yeah.
Awesome. And then Blake and Matt, do you have anything you'd like to add to that?
Yeah, so this year it was kind of interesting for us because the 8th graders joined the same building as the freshmen through seniors. So we took a different approach because half the team with 8th graders, and anyone who wanted to work with the CAD guys was welcome to, and a couple of the kids did. But the other ones were really interested in, how do I make these parts? So mostly it was upperclassmen doing a lot of the design, and then the 8th graders were in the shop working really closely with some of our technical mentors on how to use the Bridgeport, how to use the router, how to use all the equipment to make the parts that were coming out of the design. So I think that part of the learning there was having the kids understand how parts are made feeds into the design process, so that when parts are being designed, it's like, oh, I know how to make this. I'm going to make it in a way that we have a machine that can do those operations.
I think also what we did too, we dangled carrots in front of the kids in terms of like, hey, you want to learn how to use the new laser cutter or the 3D printer or the router or whatever it may be. And then so it's like, all right, well, you want to do that. Well, CAD and Onshape is the vehicle to get to, making your own, we make our own Christmas ornaments, or, any kind of like, even like little things aside from robot things to say, they could bring it home to their mom and dad, be like, look at these cool things I made on the Epilogue laser that, I've made in Onshape, and I can make it, and I can change it, and I can do things like that. So sometimes CAD was the vehicle to get them to do, something that might have been a little cooler.
Awesome. Yeah, I know I've made a few things in Onshape that I've printed just for fun for myself. Made a bowl for my cats. So then another question I'll pass back to Matt and Blake. How do you divide up the robot space into those different subsystems?
Wherever you want to go, what your interests are. We're not too structured with that. If we see that one group is a little overloaded, we might make a move. But I think we want kids to work hard and be really interested and inspired by what they do, and we kind of let them follow what their interest is and see how far it takes them.
Awesome. Julianne, do you have anything you'd like to add to how you guys divide it up? I know you said you mentioned you have a smaller team, so how do you divide and conquer with a smaller team?
Yeah, so when we kind of settle on what we kind of want our robot to look like, that'll tell us how many different mechanisms we have, and some of those will end up kind of being more complicated or taking more time to build than others. But generally, we divide our team into groups based on what people are interested in building and how many mechanisms there are. So like there might be a group for the drivetrain and a group for the lift and a group for the claw and a group for the intake, but whatever those are, we just try to figure out like what people want to work on, and then we try to make groups around what people are interested in, so that everyone kind of gets a chance to work on something that they really want to.
Very cool. Dominic and Ty, do you have anything else you'd like to add to this one?
Dom, you're muted.
All right, so 319, we've been able to use Onshape in a way that, like, come build season, when we're working on the robot CAD, there's kids out in the mill shop making the parts, and say someone's working on the CAD and makes a change to it. Well, since Onshape is a web browser-based CAD, person can be out in the workshop and they'll constantly see the updates made. So that's definitely allowed our team to divide our teams up and have like 3 people working in CAD, 3 people working in manufacturing, and so on and so forth.
Yeah, and to more specifically on this question, what we did this year was there was kind of a hierarchy of how we wanted to allocate space for the robot. Obviously, the robot needs to drive, so we started with allocating space for that, and we had decided that we wanted to be a tall robot. So we did something similar to what 1678 showed earlier when they were showing their design, in that we put the shooter at the top back of the robot, and then from there we designed the collector that could collect balls, and then the ball, everything that got the power cells from the collector up to the shooter had to fit in the rest of the region. So we kind of decided what was important, placed the most important parts where they needed to go, and then the least important parts got the space that was left over.
Awesome. And Eric, what about you? What about your team, where you had a larger number, you said, this year working on the robot?
Yeah, I mean, we do a lot of 2D sketches, even before we decide, the robot archetype. And this year the robot could only hold 5 balls, so put up kind of a box and in the sketch and drew 5 circles at 7 inches or whatever the ball diameter was this year, and showed how they would fit in the robot, and knowing that we want to hold 5, so whatever we're going to do has fitness, and we're going to be. And then I fought for tall because we grew from like 12 kids or something like that to like 30 kids, and over I think 22 of our students this year were second year or younger, so like they didn't have a lot of experience. So trying to fit everything in a small box like Mike's team, that just wasn't something I knew that we would be successful at this year. So I mean, so it was like I fought for tall. I had a bunch of other people fighting for short, and I was like, tall is what's going to be successful. I was like, do we want to build a really complicated robot that's going to fail, or do we want to try and do something that wins? And so finally, tall won out. So we did what Ty did. We threw a shooter up at the top of the robot and kind of just went from there.
And Mike and Nathan?
Yeah, McKenzie, could you give screen share to Nathan again? He's got a mock-up CAD that we wanted to show kind of how we laid things out. We showed the overall CAD earlier of the robot, and so hopefully what Nathan shows at least looks somewhat similar. But Nathan, you want to walk through this a bit?
Yeah, of course. So this is just the preliminary part studio where we did the design and space allocation for this robot. So generally we kind of decide on drivetrain dimensions kind of arbitrarily, like based on educated guesses of how things are going to fit together. And based on that, here, let's go into the sketch here. We just start doing some sketches, it's covering my, there we go. Just start doing some sketches. We initially thought we might want to fit 6 in, and obviously the wheel doom has to go near the front of the robot. So we put this here, and then we have some space in the back for the climber. And then the drivetrain gearboxes had to fit right here and over here. So in that way, we kind of figure out, well, in this sketch, we didn't really figure out how the intake was going to fold up yet, but we know, okay, the climber is going to or I guess here, let me go to the assembly real quick. But we can kind of model out, okay, this is going to fold up and then go up, and then this is going to spin around, and just see how everything fits together before we actually start designing in detail. Yeah.
And one question I have for 1678 is, how did you make sure that something that was packaged like this in your preliminary sketch, how did you make sure that it maintained that general space as you broke it up into multiple different documents?
Yeah, so all of our documents, I guess, start out with the defining geometry, right? So as long as you kind of copy paste that over, everything will be the size that you intend. And as long as everyone kind of understands and is on the same page on like where you're going and how you want the CAD to fit together, obviously there's a lot of communication involved in that. we'll be good to go there.
Yeah, I'd say our biggest issue was we had a one intake version that didn't properly account for the shooter size, and so on I think it was on beta, one of our robots, if depending on the position of the turret, the intake was spinning against the intake shaft was hitting the turret as it swung around, so it made a nasty noise in certain spots, not all the time, but in very specific spots, it was not good. Yeah. Important to keep your versions together and keep good checks and communications throughout the development process.
Yeah, for sure. That's one thing about having the separate documents. You got to make sure you're updating each assembly separately to make sure nothing conflicts in the top level.
So that actually leads pretty well into one of our next questions. It's not the next top one, but I'll skip ahead. How do you guys integrate the versioning and Onshape? Do you use the versioning and Onshape typically as you go through?
For us? Yeah, sure. So having different, I guess we have to make versions to be able to update the top level. But also just a general rule of thumb for this year, and we did it last year even when we had everything in the same document, is we just made a version every night or before every competition or before any major change and just labeled it. So say like, okay, we tried this assembly out, but it's not going to work out. So I just make a version before I delete it saying before 400 assembly delete and make a version. So we can always go back if we need to. So yeah, we definitely use versions heavily.
Awesome. Ty and Dominic, do you also use versions as you go through, or do you have a workflow that you kind of typically keep your team to?
Yeah, that was basically the same approach where we use the full history tracking or the full change tracking that Onshape has. But if we ever did anything scary or right before a competition, we would add that version and mark it so that we could go back. Back in 2017, we actually split and used the different workflows, and that actually worked out pretty well and kind of let different team members go down different paths of certain designs. But we found that we'd rather have that done in kind of like a different part studio instead. And so we abandoned that in 19 and 20.
Yep. Julianne, what about you? Have you guys been using versioning in your designs?
We haven't really been using versions because our team hasn't quite gotten there yet, but I believe we did use the few times when we had to kind of redesign our robot halfway through the season because the intake wasn't working as well as we thought it would. So I believe we versioned it then, but we haven't really been consistently using versions throughout like our CAD process.
Yep. Awesome. And Eric, what about you?
We haven't made a conscious effort to use versioning. It did save us this build season. Something happened and it lost on a whole assembly, but we were lucky to figure out how to go back. So we'll probably make a more concerted effort in the future to make actual versions. But generally, we kind of like how we do, like we just make prototype after prototype after prototype and then kind of CAD as we go along. And so nothing really gets put in a full assembly until we feel the prototype is good enough to make a robot from.
Awesome. And Blake and Matt, do you guys use versions in your workflow?
Yeah, so there was a time, I think it was last year, that just like you just said, something happened. Multiple assemblies were all red. There was no part showing. The student said, I don't know what happened, ? And we were able to, roll back through the history to a good point in time and then keep going forward without too much hair lost. But other than that, it's kind of like a weekly, yeah, we're in a good place. The CAD's been cleaned up, save a checkpoint and keep going.
Awesome. And then I'll ask this next question to all of you. How do you delegate tasks for your CAD team? We can go back to Blake and Matt if you're available to answer that one.
Yeah, so it's mostly student managed. They kind of pick what they want to work on, which I think keeps it kind of interesting. This year we did a little more, we tried to do some tracking in a spreadsheet and assigning part numbers, and every drawing had a number or a name assigned to it, and we kept the parts labeled because the design and manufacturing were kind of disjoint. Definitely we kind of suffered because that wasn't as good as it could have been, and hopefully next year we'll improve those processes, and maybe the Onshape enterprise features might be available to educational users, which if that was the case, we'd be very excited and happy to use.
Hint, hint.
Definitely taking notes, I promise. Awesome. Ty and Dominic, do you guys delegate tasks for your CAD team in a specific way?
Go ahead,
Yeah,
Dom.
for the most part, we do. We usually have like team meetings. So when we break off to our sub teams, like our CAD team, we'll see what has to get done. Say it's after competition, we took note that like our collector didn't work, something malfunctioned. We'll have kids go work on specific parts, and we'll be able to process things better.
Yeah, one of the features that we use is the ability to put a comment on any feature or any part in Onshape. So I can log in when I'm on some work trip or something, look at the designs that the students have gone through and make comments and changes without having to bug them on Slack and say, you know, that blue part next to the other green part that's on the shooter, because we haven't gotten to the part numbering side of things yet. So everything in our Onshape document is like part 1 or shooter left side or something. So the ability to just add those comments and have them marked as resolved is very useful.
Awesome. Julianne, do you have any way that you guys delegate or manage your tasks in the CAD?
Yeah, so as FTC, we're kind of a smaller team, which means that, like as I said before, kind of the CAD team is pretty much the entire team. So once we do kind of have our groups for different mechanisms, the people, specific people who are like more experienced in CAD will kind of lead that group, and then they're kind of in charge of like checking over the CAD once we think that it's complete before we 3D print or laser cut parts to assemble, just to make sure that kind of everything's in there that needs to be there. And so we just kind of make sure when we delegate tasks for the CAD that they're and we have like enough people working on like a specific part or mechanism, and that there's not like too many people or too few people that it would become overwhelming for anybody. And we just kind of make sure that everybody's included in the process of like designing and building the robot, so that it's not like too much stress on one particular person. And we just kind of go with that, and then kind of figure out like what the mechanisms that the groups are doing, and then have someone check over what we've done before we're ready to like actually manufacture.
Awesome. And then I'll pass this over to 1678 next. Mike and Nathan, if you're available to answer this one.
Yeah, so in general, or I guess at the beginning of build season, we do a few days of figuring out a general direction and what we want to prototype initially to make sure it works before we actually put it on a robot. So everyone is included in prototyping, and the way we kind of delegate parts of the robot is by who is leading that prototyping group. So we'll have designers split off into whatever they're interested in, and kind of we'll have a lead designer for each prototyping group, and that designer is generally who will be doing the CAD for that given assembly, assuming that we deem the prototype suitable for competition robot.
And in general, those leads on the design are veteran designers, and we usually have a pool of about 6 to 10 additional younger designers that are available to support the lead designers on tasks within sub-assemblies. So that could involve creating part numbers or generating, maybe the lead designer throws in all the plates and the major geometry and wheels and such, but the supporting designers make shafts or 3D printed parts, things like that. And then as far as review goes, generally Nathan and myself are doing all the reviews for subassemblies. So typically a designer will just post in our Slack and say, hey, you know, O200 is ready for a review. Can you take a look at it? And I'll go in and view it on Onshape on either my computer, or what I love about Onshape is I can do it on my phone. So a lot of times I'm doing CAD reviews at like 4 a.m. when I wake up thinking about robots and want to make sure the design's going well. So I'll just take screenshots on my phone and highlight areas that need fixes and just post that in Slack threads.
Awesome. And then Eric, what about you? Delegating the tasks for your team?
Yeah, very similar to 1678s. Like I said, we actually start prototyping Saturday of kickoff. So in the afternoon, so we kind of, I'm like, hey, like this year I was like, who wants to work on prototyping shooters, and get a group of kids who wants to do that, make sure there's some CAD students in it. One of them ends up being the lead shooter CAD kid, and then have drivetrain and intake and or whatever, climber, stuff like that. And they just, you know, all work together and start prototyping parts, draw some stuff, and making sure that before we get to like a finalized CAD or whatever, that the prototype is something that we actually want to move forward with on a robot and go from there. So I do most of the reviews by myself. I do it with the students sitting right there, hopefully, on the days that I'm there, more than doing the screenshots. We use the app actually as our assembly drawing, so kids are pulling up the model on their phone while they're building the robot physically. So because everybody on our team rivets and assembles a robot, it doesn't matter what you do on the team. So it's not just CAD students. Any student can pull up the app on their phone. I'll pull up the robot and know that they're gonna make whatever they're making correctly, which is really nice.
Yeah, absolutely. I know a few times in my past there's been some wrong measurements, so it's always good to have that right there available to check rather than walking over to a whiteboard or something else where it might be.
Yeah, we had a student this year, he brought in a laptop into the manufacturing closet, and I call it a closet because it's like a 12 by 16 foot room that has all our manufacturing capabilities in it right now. And just kind of had the screen up while he was making parts, and then created a Trello board so he knew what to make and what was ready to be made, and we could add stuff to it for him. It was cool.
Very cool. Not an Onshape question, but I'll give it to you anyway. 1678, have you ever designed a swerve?
Oh, we've never done our own module, but we compared two different COTS modules last off season. And then we have some other stuff that we're working on as well.
Awesome. And so anyone who uses CAM, what do you use for CAM software when you're using Onshape to design? I don't know if anyone wants to take that one first.
Yeah. We use Fusion 360 for now. I mean, we're getting a bunch of new equipment this fall, so it might change based off the equipment we get, but Fusion 360 right now.
Yeah, we do as well. It's pretty smooth, and you know, makes life as easy, but we would love some sort of integration in Onshape.
Yeah,
Again, taking notes.
We use Cut2D Pro for all of our routers, as well as our laser cutter, I think.
Yeah, and I'll add that process, while it works, you know, again, I think I'll echo Matt, that'd be great to have some intuitive built-in CAM solutions that are accessible. I think the one or two that are available right now are paid subscriptions that are just kind of out of our budget range. And you know, for every part that we make, we need to right-click on the you know, the 2D surface and export to DXF, and then throw that in a different CAM software. So it'd be great to have that incorporated, you know, down the road.
Absolutely. Great. And so another question, we can go through each of the teams. So how many team members usually are using Onshape? So we can start with Ty and Dominic.
For our team, usually I've seen at most like 10 kids doing Onshape, and that was mainly a year ago when we had a bunch of freshmen join. So we had a lot of kids kind of figure out what they wanted to do. Yeah.
Awesome. Yeah, and something we're trying to figure out, we haven't found a limit yet, but what's the largest number of people you've had working on a document at once?
I think the most we've ever had in our document at once, I think we had 10 or 15 during a larger CAD review at the end of the year, where people were logged in and reviewing different sections as we went, and then we got together and reviewed it as an overall.
Yep. And Julianne, how many team members do you have that are usually working? I know you said you have a smaller team.
Yeah, so our team is about 14 people, and there probably have been times when there were 10 to 14 people working on the CAD at kind of like towards the beginning of the season when we were making some custom parts. But yeah, so it varies a lot because a lot of times when we do CAD, we do it all at once, which means that a lot of people are on it. So that's usually about like 10-ish people on the CAD.
Awesome. And then Eric, what about you? How many people have you seen working in? I know you mentioned you have 12 people this year that were working, but how many are usually in the document at once?
I mean, we generally on days I'm in the shop, 5, 6 of us are in at the same time. Right away during like at the beginning of build season when we're all doing sketches and all sorts of stuff. I mean, we get 10 this year, but like I said, we're small. I'd really like to hear what Mike and Nathan say, having 100+ kids on their team, how many they get in there Onshape.
Yeah, absolutely. We can pass it over to Mike and Nathan next.
Yeah, I mean, like I said, we use separate documents for all of our assemblies. So this year it definitely was like 1 or 2 kids in each document at once. But we did the full robot in a document last year, and I'd say it got up to 10 or so at once during meetings. And keep in mind, I'm pretty sure having multiple browsers open on the same assembly is the same effect as having 2 people.
Yeah.
So I'd say probably like 15 browsers at once.
Yeah, and we're also the students are doing a lot of work at home too. So it's not like a lot of times our lead designers aren't actually doing CAD at the meetings. They're worrying about overall assembly and manufacturing pipeline. And supporting designers are in the Onshape during meetings, and a lot of times our lead designers are working at home. So the work gets distributed a little bit more, and there's not as much like workflow concentration in those couple of hours in the shop.
Awesome. And then Blake and Matt, how many team members do you typically have working in Onshape? And what you had the max?
I've seen as high as 15. A couple of years ago, we had a couple of Onshape snags, but we've seen a considerable improvement in performance since then.
Yeah, I think every now and then we might even peak at 20 if we've got a lot of kids and a few mentors working on it at the same time.
Wow. Awesome. All right, we're gonna keep this the Onshape questions. Get rid of those ones. So we talked through those. What are some of the creative or unorthodox ways that you've used Onshape? So I know people mentioned some off-season projects or having team members do things at home. I'll pass it back to Matt and Blake if there's anything specific that you've seen teams do in Onshape or seen your team do in Onshape.
Yeah, not a lot really pops to mind. A lot of the 3D printed parts I think might come off as unorthodox, and the ornaments that the kids produced, models of Star Wars ships and other little things like that were kind of interesting. But
Awesome. Does anyone else have anything that they've done that kind of stands out that they've done not robot related or robot related kind of different?
This is a little different. Do you mind if I share my screen really quick? I'll be quick. Let's see how this works out. Okay, which screen is it showing? Let's see.
It says parking.
The document.
Oh,
Yep.
okay. Here we go. Is this working?
Yes.
Yep.
You able to see this now? Okay. So this is a scouting tablet case that one of our designers designed in the fall in order to organize all of our phones and tablets for competition. So they were able to find the solid case model of, this is kind of like a Pelican style road case. And then they used a lot of the like laser joint features and stuff like that to create a inlay that was made out of a bunch of different laser cut pieces of wood to drop into that plastic shell. And then you know, did a couple cuts and tests, and it actually was really nice we were able to do this in Onshape because I was able to give a lot of like reviews on kind of the ergonomics of it. We had other people on, not on robot teams. We have like a software scouting team review this design as well. And then we had there's I think 14 tablet slots and 2 phone slots in each of these, and we have 2 of these cases for a total of 28 tablets and 4 phones that we take to competition. So it was really nice to get all that stuff organized this year into road case or into cases that we're able to take as carry on a plane. So it all got really convenient this year doing it this way.
Awesome. Any other projects that people would like to share?
Yeah, so a few years ago, as part of our outreach, we decided to try to design and make dog wheelchairs. And we used Onshape to design like certain parts for that to connect like different parts of that. So that was something kind of different from robots that we did. We also used Onshape this year to make our pins that we like gave out to other teams at league events.
Awesome. So we are getting short on time, so I'll go through a couple more questions pretty quickly. So the experience in switching from other CAD software, something about Onshape that surprised you the most? I don't know, I'll start with Ty and Dominic again.
Mm-hmm.
You want to talk about that?
Yeah, the thing that got me the most was the multi-part studios and how flexible you can make your designs. When I first, like I said at the beginning, when I first started switching to Onshape, I designed it where each part was in its own part studio, and then I would assemble from there. And it just seemed like an incredibly clunky interface. And then I found out I was using it wrong. And so the multi-part part studios and the mate connectors during assembly, it's really made me realize that there is definitely not just one way to do 3D CAD.
Absolutely. What about you, Julianne? Is there anything that surprised you, or did you switch from another CAD tool that you noticed anything in the switch?
No, Onshape was the first CAD tool that our team used, but I think that I don't know, something that we find very helpful with Onshape is just the fact that it's collaborative, because sometimes there's someone like working on a part and they might not really like know how to make it, and it's really helpful when someone could kind of step in and check it over from like their own computer, or even like working on it when we're not like necessarily in the robotic space, but like from home we can work on Onshape stuff, and we don't necessarily have to have like any particular software, but we can continue to work on the robot from different places.
And what about you, Eric? Did you switch from another CAD tool, and anything you noticed in that switch?
Yeah, so we were Inventor before we switched to Onshape, and that was mainly because that's what they teach in schools. I think the biggest thing that, like the biggest learning curve, wasn't necessarily the part studios. I had talked to people who had been using Onshape before, so that was something they had to stress right away, but it was just learning the mate connectors and all that. I think because you have to think about assembling things differently in Onshape than you do any other thing, and I like it much better now. I mean, one mate, and I can fully constrain 2 parts together, which is pretty cool. So.
Absolutely. And Matt, have you had anything in your switch over?
Yeah, so our first 3 years we used another product, and it was really, really hard to get our kids bought in to use. It was cumbersome, it was difficult to use. You know, we were tied to computers in the lab because it was, you know, station-based. You know, if the student checked out a part, and they didn't check it back in. We were trying to get a hold of a kid to make that part available. So, our first couple of years, we had maybe max 2-3 kids that were confident with this program. But then, starting our 4th year, we jumped onto Onshape, and, all of a sudden, every kid was using it, right? The usage exploded, and I think that the quality of our robot and the quality of the design and what we were able to accomplish really, took off because we had more kids interested, and it was much more accessible. We didn't have to be in the school. We could do it at home. There was all kinds of different places, and truthfully, I feel like it was a little more intuitive than the previous program that we were using.
Absolutely. And Mike and Nathan, did you have anything that surprised you in your switch over to Onshape, or anything that you noticed?
Yeah, I think for me, it was just the part studio and the way everything was laid out to do multiple parts in a single part studio. And to be honest with you, I don't know how we did it in SolidWorks. Partly because I don't really remember, because I only had 1 year of experience on it. But also in a summer internship last summer, I had to use SolidWorks for like a sensor mount, and having to open up a new document to make that part, and going back to other documents like measure out, okay, this hole needs to be here and this hole needs to be here. Just so cumbersome coming from Onshape. So that's something I really appreciated.
Yeah.
Yeah, from a high level, the accessibility and no installs and ease of collaboration, I've been surprised at how well that's facilitated more students diving deep into the design than what we were using in the past. So happy surprise there.
Absolutely. All right, we're running low on time. So we can do this one kind of quickly. If anyone has any specific methods they'd recommend for teaching, and we talked a little bit about introducing new students, if there are any specific resources that people would like to call out that they think were helpful in teaching new students.
Yeah, I heard there's this great series of webinars focused on using Onshape in FRC.
That's definitely great to call out. We have them all recorded on our PTC YouTube channel for people who this might be your first one joining, and this will be recorded and put up there as well.
Yeah, and definitely encourage teams to structure a lot of their trainings around the Onshape Learning Center, and having students send copies of their certificates when they get those sections completed. It'd be nice, another tip, if possible, being able to integrate like the Learning Center into Onshape teams, so we could see, which user accounts have completed which trainings. That'd be pretty cool from like a team management perspective. But in the meantime, we have students send us their certificates when they've completed various Onshape Learning Centers, and that's been a great intro to the platform.
Awesome. And then one thing I'm just gonna skip ahead to, what workarounds do you use in place of the not having the length dimensions in assembly mirrors? I know that's something a lot of people have talked about, and definitely something we've mentioned to our product management team. But if you guys have any specific things that you do to work around these things for now, that you'd like to share to do those assembly mirrors.
I mean, for inlay, so we've just intentionally avoided complicated paths for belts. So we do simple point-to-point belt paths and chain paths, which there's plenty of great calculators online to use that to calculate centers. I don't think we have a ton of creative tricks for assembly mirrors. I don't know if Nathan has anything to share, but maybe some other people have better tricks for how to improve their assembly mirror workflow.
Yeah, I mean, this year it wasn't like, I mean, aside from like your bearings and all of that, which is not too hard to like throw a couple more in there and mate them in each assembly. But like for our turret, the circular pattern feature worked great. So there are other features for other applications. Obviously, it still would be nice to have the mirror.
I found to myself not to be missing the assembly mirrors that often, mostly because of the replicate tool. The replicate tool seems to be making things really, really easy for me. And then one of the lessons that our team learned throughout the years of design practice was that as much as we think two parts are going to be symmetrical left to right on the robot, they very frequently end up not being so. So we take the approach of designing, just designing all of the, for example, like all of the tubes that we would have on the assembly, we just put them in the part studio too. And we don't really worry about trying to mirror and reduce the number of parts.
Great. And I think I saw at least one question about the contest itself, about the size restrictions.
Yes,
Oh, you can go ahead. Oh, sorry. So for the contest, the FRC and FTC size restrictions are separate. So if you look at the website, there's the FRC robot requirements and the FTC robot requirements. And so those are entirely different just because it's very similar to the form factor you'd find in a typical season. And then I don't want to keep the panelists all night, so I apologize that we didn't get to all of the questions, but I do want to thank you all for joining us. Definitely very appreciated to have you all here. Definitely a great panel. And again, it will be recorded, so any of the earlier questions I will ask, if you missed any of those, you can definitely go back and look at that recording. And then just a reminder, we do have a couple more webinars left. So preparing your submission, and then that office hour. So hopefully I'll see a few of you at those ones as well. And thank you again for joining us, and feel free at any time. If you have questions, if you had something we didn't get to tonight, you can always email us at first@ptc.com. So thank you and have a great night.
Thanks.
Good night.
All right.